Hello students, myself Ramesh Kothari welcome you all in the world of fermentation technology. This lecture is a part of Anemia City project, an initiative of Ministry of HRD, Government of India. Today, we will focus our discussion on Ancillary component of fermentation media part 1. In this lecture, we will discuss the importance of minerals, chelators, growth factors, buffers, and precursors in the fermentation media. We will start with minerals. Mineral elements like potassium, phosphorus, magnesium, chloride, calcium, and sulfur are essential for growth and metabolism of microorganisms. In addition to this, other such elements like iron, cobalt, copper, manganese, molybdenum, and zinc are also crucial for growth of microorganisms. These trace elements are present as impurities of water and can also be supplied as impurities of common salt and minerals. Concentrations and the range in which these minerals are generally added are given in the following table. You can see from the table that the minimum range of molybdenum, that is 0.0012, maximum range of potassium dihydrogen phosphate, that is 1 gram per liter. The concentration of minerals to be added in the medium may be vary significantly depending on the fermentation process. For example, the process in which the product of interest is secondary metabolite, they require lower tolerance range of inorganic phosphate than the vegetative growth. As it is assimilated at the end of the trophophase, its concentration should be adequately low. As reported by Garner and his co-workers, excess inorganic phosphate can be precipitated out by the addition of calcium salt, and simultaneously it also enhances the overall yield of streptomycin. Following table shows the effect of concentration of trace metal on the production of primary and secondary microbial product beside its requirement for maximum growth. You can see from the table that trace elements manganese, which is required for the production of bacitracin. Manganese is also required for the production of protease. Cobalt required for production of gentamicin. Iron and cobalt required for the production of riboflavin. Iron also required for monensin. Iron and zinc are required for the production of actinomycetes, candicidin, chloramphenicol, neomycin, portulin, and streptomycin. Iron, zinc, and coppers are also required for production of citric acid, penicillin, and zinc required for gisofulvin. As stated by Foster, in fungal metabolic system, chlorine is not required. As reported by Rhodes and his co-worker, in the fermentative production of gisofulvin, the sufficient available chloride is supplied by the addition of 0.1% KCl. Chloride can also be made available by addition of crude nitrogen sources. Now, chelators. Several media, when subjected to autoclave, form visible precipitate insoluble metal phosphates. As reported by Gaunt and his co-worker, formation of a white precipitate of metal ion containing all the iron and most of the calcium, magnesium, and zinc present in the medium was observed when the medium of Mendes and Weber was autoclaved. To cope up with this insoluble metal phosphate precipitates, the addition of a low concentration of chelating agent such as ethylene diamine tetraacetic acid, that is EDTA, polyphosphates and citric acid solve the problem of this precipitation. By adding this compound, it chelates the precipitate and make available slowly to the organisms. In a medium, these chelating agents preferentially form complexes with metal ion, and microorganisms make use of this metal ion gradually. The concentration of chelating agent should be optimized, as over supplement of these agents may be detrimental for producing organisms. Many times, it is not required to add chelating agent in the media during large-scale fermentation processes. The yeast extract or peptone-like complex ingredient present in the media make the complex with metal ion and ensure gradual release of these metal ions during the growth. Now third, growth factors. Some organisms need pre-formed compound, popularly known as growth factors, as every organism cannot synthesize almost all the basic requirement to build up the cell component. The commonly required growth factors like vitamins, selected amino acids, fatty acids, and sterols. As reported by Atkinson and Mevituna, the need of some or many required growth factor can be satisfied by natural carbon and nitrogen sources which are added in the media formulation. As reported by Rhodes and Fletcher, the vitamin deficiency can often be satisfied by careful blending of materials added in the medium. But in case when there is a need of only one type of vitamin, it is very costly to add in pure form. In 1967, Beman reported that calcium pentothenate can also be used in one medium formulation for vinegar production. A limited quantity of biotin must be present in the medium in glutamine acid production. As reported by Kinoshita and Tanaka, a few strains may also require thiamine. Now, buffers. Microbial growth is pH specific, and thus the control of pH is very important if optimal yield is to be achieved. Certain compound can be added to the medium to serve exclusively as a buffer. Many media are buffered by the incorporation of calcium carbonate at about pH 7, and during the process, if the pH decreases, the carbonate is decomposed. Phosphate is an important part of several media. Many times, phosphate play an important role in buffering during production of secondary metabolites. The pH of the medium can also be controlled by balanced use of carbon and nitrogen sources, because buffering capacity can be provided by the amino acid, peptide, and protein present in the corn syrup liquor. Addition of sulfuric acid, ammonia, and sodium hydroxide is also an alternative way to control the pH externally. Now, precursor. Instead of rather supporting the growth of microorganisms, a number of components of a fermentation medium assist to regulate the production of the fermentation product. These additives are called precursors, inhibitors, and inducers. These compounds can be exploited to influence and manage the progress of the fermentation process. When we add certain compound in some selected fermentation processes, these compounds are directly incorporated into the desired product. For example, for improving penicillin yield, precursors are added. A variety of diverse side chains can be incorporated into the side chain of the penicillin molecule. Constiplica, which was found to contain phenylthiamine, when added in the medium, improved the yield of penicillin from 20 unit to 100 unit. It was found that phenylethylamine present in the constiplica preferentially incorporated in the penicillin molecule to yield benzyl penicillin. As we know that the activity of penicillin rests in the side chain. The limiting factor to synthesize active penicillin was the synthesis of its side chain. Now, it has become a normal practice to add the side chain precursor to the medium in a particular phenylacetic acid. As reported by Smith and Boyd, the production of penicillin can be increased 3 times when phenylacetic acid and its derivatives are added in the medium. As on this date, the phenylacetic acid is the most widely used precursor in the penicillin production. Following table shows some important precursor useful in the fermentation processes. For example, phenylacetic acid and other related compounds are used for the production of penicillin G. Phenoxyacetic acid used as a precursor for the production of penicillin V. Chloride used as a precursor for the production of chlorotetracycline. Chloride also used for the production of grisofulvin. Propionate is used as a precursor in the riboflavin production. Vitamin B12 production requires cyanides as a precursor. Carotenoids production require beta-inonones as a precursor. So, precursors play an important role and indirectly it affects the fermentation economics. So, this is all about ancillary component of a fermentation media part 1. Thank you very much and have a good day.